Hello, this is Dr. Oz. Today, I would like to talk about the measures of association. And this is very important because when we make in the future predictive analytics, we will look at historical data first to understand the relationships between multiple variables. However, it's very important to note that these relationships do not necessarily mean that there's a causal relationship between those variables. So, in other words, I cannot really say directly unless I have an experiment designed very well that independent variable X cause dependent variable Y. However, if I understand the linear relationship or association between two variables, with my managerial experience, I may be able to end up with that conclusion. All right. All right. So I will cover scatter plots, covariance, and correlation coefficient in this video. So let's take a look at an example. I have here temperature data, and here I have bottle sales. And I want to know whether when the temperature goes up, that's my hypothesis, that my water sales will go up, or when my temperature goes down, my water sales goes down. To be able to test this, I mean, I could just take a look at the examples one by one. Let's say from 78 to 79, it increased, but my water sales decreased. So can I just say that there is no positive correlation between these two? It is hard to tell from looking at individual data. That's why we use scatter plots. In scatter plots, we put the independent variable. In this case, this is a predictor, high temperature. And in my x-axis, and the y-axis is my dependent variable, or the variable that I'm trying to predict. In this case, the sales. So when I plot these data points that's given in previous table, I got these dots. So if I try to find the best fitting line to these dots, as you see, looks like they're very close to the linear line that I was just drawing. So I may be able to say, hey, there is a good relationship between these two. And I know that water sales will not impact the temperature, right? I mean, I cannot, if I drink more and more water, I cannot increase the temperature. However, based on my experience, I can tell that if the temperature is higher, people will get more thirsty, they will sweat, they will get tired, and so on, and they may consume more water. So, and you can see the positive relationship between these two because the slope of this red line here is positive. All right, so let's take a look at our Excel file. So here is the Excel file that I have for you guys. So I put that data into my Excel file, independent variable temperature and dependent variable sales. So let's create a scatter plot out of these two. So what I like to do is just highlight these two columns and then insert, and then you will see here scatter, and click on scatter, and that will create your scatter plot. And I really like to have my axis labeled because I don't know what this is. I don't know what that is. So it's important for your figures to stand alone. So what I'm going to do is click on this chart elements, and then here you will see axis titles. And now I click on that. My y-axis is my dependent variable, water sales. I like to have my units in my figures too, so in cases. And my x-axis here is the temperature. And the unit here is degrees Fahrenheit. All right, so you can see the positive relationship between these two variables by doing this. Another way to see this relationship is called covariance. And Excel, it's pretty easy to calculate covariance in Excel. Just type covariance, and Excel will give you two different options here. One, covariance of the population. Another one is covariance of sample. Since it's sample data, I will use covariance of sample. It's important to note that covariance of sample will be higher than covariance of population for small data sets like this because there's more margin of error. All right, so let's click on this. And the first array here is the independent variable, comma. Second array is my dependent variable, which is the sales. And then enter. So my covariance is 12.8. That means that there is a positive relationship. However, I really don't like to have covariance because it has units and it's hard to understand what's going on. That's why we use correlation. And correlation normalizes covariance, and it doesn't have any unit. That will make it easier to understand, and it's again easy to calculate. Correl independent variable first, comma, dependent variable, and enter. So you will see that there is a 93% correlation. If you do other way around, dependent variable first, and then independent variable, and then enter, you will get the same result because it's a square matrix, correlations between two variables. All right, so what does it tell me? There is a really, really high correlation between temperature and the water sales. What it means? What does it mean? When the water sales goes up, the temperature goes up. When the temperature goes up, water sales goes up. When the temperature goes down, water sales goes down. Again, this doesn't say anything about the causality. However, based on my experience, I can say there is a causal relationship. Why? Because when temperature is higher, which is independent variable, my sales will go up. But I cannot say vice versa based on my experience. It's ridiculous to say that if the water sales goes up, then temperature will go up. All right, that's not going to cause that. And the correlation coefficient can get maximum 1, which shows very, very strong positive relationship. In this case, it is pretty close to 1 or 100%. And if the correlation coefficient is 0, that means there is no linear relationship between those two variables. If this value is -1, that means that there is negative correlation, very strong negative correlation. And again, correlation and covariance, these factors, they are showing the relationship linear, like linear line. You may have data that is not linear and you may have relationships. So you cannot just say that if this value is 0, there is no relationship between two variables. You should say there is no linear relationship. All right, so that's it for today. Until next video, enjoy business analytics.